Assalamu alaikum. So today we are going to learn about the chapter 4 periodic table. The chapter was being discussed in the class. Basically it is not discussed, it was being revised. So today we are going to learn the portion which is called periodic properties of the element. And you already know what is the definition of periodic property. We know that the characteristic, physical and chemical characteristics which alternates according to the group or periods are called periodic properties of the element. Now, how many periodic properties are mentioned in our book? 5 periodic properties are mentioned in our book, and you know the names: metallic property, atomic radius, electron affinity, electronegativity, and ionization energy. So we will start from metallic property. What is metallic property? In the previous or the junior classes, we used to learn a very simple definition of metallic property, which is it conducts heat and electricity. It makes a special kind of sound when it is heated with something. But in class 9 and 10 for S.S.C, we need to learn the advanced or the modern definition of metallic property, which is the electronic definition. The elements which atom can give one or more electrons and convert into positive ion are called metals, and this property of the elements or atoms is called metallic property. So we know at the left side of the periodic table, the most metallic elements are there. Whenever we go from left to right in a period, gradually the metallic property decreases and non-metallic property increases gradually, and the elements which are at the rightmost side of the periodic table are most non-metallic. Okay, so this is the discussion about metallic property and non-metallic property. So when we go from left to right in a period, metallic property decreases, non-metallic property increases. So what happened when we go from up to down to the periodic table in a group? What happened then? We know that atoms can release or donate electrons when the attraction force between the nucleus and the electron at the orbit is lower. Then that atom can donate electrons much more easily, and the electrons that can donate electron easily are more metallic. So when we go from up to down in a group, then atomic size increases. As a result, the distance from the nucleus to the electron, it also increases. As a result, the attraction between the nucleus and the electron decreases, so that electron can be donated easily. That means the metallic property increases. So when we go from up to down in a group, metallic property increases gradually. So this is the discussion of metallic property. That means if I talk about potassium and calcium, both of them are in period 4, but potassium is at group 1 and calcium is at group 2. That's why potassium is at the left side and calcium is at the right side. That's why potassium will have higher metallic property compared to the calcium. Okay. And what about the non-metallic property? Non-metallic property is just opposite of the metallic property. That means if we go from the left to right in a period, the non-metallic property will increase gradually, and if we go from up to down in a group, the non-metallic property will decrease gradually. Okay. Now we are going to discuss about ionization energy. One of the most important topic of this periodic properties, ionization energy. So actually, what is ionization energy? Ionization energy is the amount of energy that is required to make 1 mole of atom and release 1 mole of electron from this atom and make 1 mole of positively charged ion in its gaseous form, and that required energy is called ionization energy. Okay. And ionization energy also alternates according to period and group. That's why ionization energy is also called a periodic property. Okay. So how ionization energy is a periodic property? We need to understand that. So ionization energy is a periodic property because when we go from left to right in a period, the atomic size decreases. Why the atomic size decreases? Because now when you go from left to right, the atomic number increases. That means the number at the center of the nucleus, the number of proton increases, and the number of the electron also increases at the outer shells. But none of the new shells are added in the atom. That means there are now much more positive charges and negative charges, but there is no new shell, and that's why the attraction force increases. And as the attraction force increases, the distance decreases between them, and the atom gets smaller compared to the previous one. So when we go from left to right in a periodic table, the size of the atom decreases. As a result, the attraction force between electron and the nucleus increases. So it becomes harder to remove electrons from the atom. That means it requires higher amount of energy to remove electron from the atom. That means the ionization energy of the elements which are at the right side is higher. So when we go from left to right in a periodic table, then ionization energy increases gradually. And what happens when we go from up to down in a period, in a group? And when you go from up to down, when you cross each period, one more electron shell or orbit is added in a atom. That means the distance gradually increases. So the attraction force between nucleus and electron continuously decreases. As a result, it requires lower amount of energy to remove electron from the atom. So the ionization energy decreases in that way. So what have we learned? We have learned that if we go from left to right in a periodic table in a period, then the ionization energy will increase gradually, and if you go from up to down, then the ionization energy will decrease gradually. And after ionization energy, it is electron affinity. Do you remember what is the meaning of electron affinities? What is the meaning of affinities? Affinities means attraction. Okay, and electron affinities means the ability to attract the electron. And how is it defined? It is defined as the amount of energy that is released when you add 1 mole electron in 1 mole atom and convert it into 1 mole negatively charged ion. The amount of energy released in this process is called electron affinity. And electron affinity is also a periodic property because it increases similarly when you go from left to right, then electron affinity increases, and when you go from up to down, then the electron affinity also decreases, just like the ionization energy. And the periodic property that comes after electron affinity, that is electronegativity. One thing I need to mention before going to the electronegativity, that is, from the definition you have understood that for ionization energy in the process of donating electron, it creates positively charged ion, and in the electron affinity, when it absorbs electron, it converts into negatively charged ion. That means this positively charged ion and negatively charged ion will make ionic bond. So ionization energy and electron affinity, these two periodic properties are for ionic bond. And now we are going to talk about another periodic property which is related to covalent bond. Okay, so first two related to ionic bond, and this one is related to covalent bond. Because the definition of electronegativity is the ability to attract the shared electron of a covalent bond. So in the definition, it is mentioned that the ability to attract the electron of a covalent bond is called electron affinity. And similarly, when you go from left to right in a periodic table, in a period, then electron affinity will increase gradually, and if you go from up to down, then the electronegativity will decrease gradually. Okay, so we can understand these three properties are similar as their periodic nature, which is, if you go from left to right, all the properties will increase gradually, and if you go from up to down in a group, all the properties will decrease gradually. But there are a few exceptions, and that is the thing that you need to search, because I have described this exactly this exception before. So you will learn this, but I am going to discuss it in a very little way. That is, if we compare between nitrogen and oxygen, then where is nitrogen? Nitrogen is positioned in group number 15, and where is oxygen? Oxygen is in group number 16. So nitrogen is in group number 15 and oxygen is group number 16. We know that when we go from right, then the ionization energy should increase. But in this case, nitrogen, the one which is at the left side, has more ionization energy than oxygen. Why? Because from the Aufbau principle, you know that half-filled or completely filled orbitals are stable. And in 2p orbital of nitrogen, there are 3 electrons, and the highest number of electrons that can nitrogen hold in its 2p electron is 6. So when it is half-filled, that means it is containing 3 electrons, then it is more stable, and it requires more amount of energy to remove electron from a stable electronic configuration. So that's an exception. Okay, and there is one more periodic property, that is atomic size or atomic radius. Whatever is discussed, if you have something written as atomic size, or if you have something where written as atomic radius, both of the thing will mean the same thing, because you know, if the radius is increased, then the size will also be increased. Okay, so we have discussed from the very beginning, when I discussed the ionization energy, if we go from left to right, then the number of nucleus will be increased, but no new orbit will be added in the atom. And as a result of more nucleus, the more protons at the nucleus and more electron at the outer orbits, the attraction force will increase and the size of the atom will decrease. So if you go from left to right, atomic size will reduce gradually, and if you go from up to down in a group, then what will happen? When you cross each period, then one more orbit will be added. As a result, the atom will get bigger and bigger and bigger continuously. So this is a periodic property, and tomorrow you will have a short exam for 20 minutes, and I am providing the questions. You must learn the questions. Thank you.